Hey, what's going on, folks? It's Mike here, and welcome to another session of My Advice here, where I'm going to be talking to you just a little bit about a question that I also get commonly asked. And this is from folks who have been students, whether in undergrad, grad school, students who've gone through boot camp, or even working professionals. And that's this question here on breadth versus depth. Meaning, if I'm going to study computer science, should I look a little bit at everything, or should I do a deep dive into one particular subject? Now, I suppose your goals might be a little bit different in how you approach this question, but let me give you a little bit of an outline here, and then I'll go ahead and tell you how I think about this problem. So here's my sort of initial thoughts here. Regardless of this question, breadth versus depth, the answer, or I think the right approach, in my opinion, or what I've seen work well in experience, is to first build your foundations. There's just a few foundational skills that you need to have in computer science. And well, the good news is most of the courses, other YouTube videos, boot camps, and so on are going to hopefully introduce these things to you. So these would be things like, well, usually have an introduction to computer science, just getting you into the basics, how to compile and run a series of, text statements and write a program. That's sort of essential. And then you'll usually get into data structures, learning about some of the different trade-offs, and start getting introduced to complexity, so you can choose which data structure will help you solve a problem. And then algorithms, which can often be an applied course or maybe more theory, but again, telling you how we choose our data structures and use them and how that affects our overall performance. Okay, and we also just get to think about, again, designing programs that solve problems in a correct way. So writing software that is correct. And then finally, hopefully folks get some exposure if they're just taking a few courses into computer systems and architecture, understanding how our actual hardware works, what's going on in an operating system, what is an operating system, and some of these things. And then depending on your university or your boot camp or maybe your self-study here, you might also wander into some programming paradigms or software design courses, again, starting to think about how to build software at scale, and that there are different paradigms for solving problems, whether it's procedural programming, functional style, object-oriented, component-based design, all these different styles that you might be, exposed to and solving problems in a different way and sort of choosing the right tool to think about things. So those are sort of the foundations that I think are useful to kind of focus on. And I found this particular site here, Teach Yourself Computer Science, has a pretty decent list of, what you might see at many different universities if you go to university, or if you're just self-studying, or if you're just trying to plan out a curriculum for yourself. Again, these are some pretty decent topics here. I would also throw in, math for CS, a little bit of discrete math. Again, maybe that comes into the mathematics portion. Maybe you get a little bit of graph theory there and a little bit of algorithms, and maybe even a little bit of linear algebra stuff all kind of thrown in here. Again, maybe that's a separate video if folks are interested. But anyways, these are just some of the foundations. And of course, if you start going in a domain of networking and stuff, you would take courses there. And that's sort of the next portion here. So that what I usually tell folks is, once you've got your breadth, whether this is part of an undergraduate program, maybe a graduate program, a boot camp, etc., then you want to start exploring some courses that sort of interest you. Maybe you're interested in graphics, maybe you're interested in artificial intelligence and machine learning here, which I've highlighted. Maybe you're interested in compilers or, computer networks or distributed systems because you're fascinated with the problems they solve. You want to work in an industry that needs those skills to solve problems that you care about and that would be interesting. That's sort of the next sort of step, I would say, in your journey. Again, if you're in a university type of environment, then you're probably going to have various requirements that help you sort of step in that direction, and that's great. But for other folks, if you're, self-studying or just sort of trying to figure this out, pick and choose, in the sense that you're throwing a few darts at a board as sort of an analogy and trying out some different things. And you can kind of see some of these skills that you've learned, like data structures, how are they applied and used in machine learning or the mathematics? Or if you've done your programming design paradigms, see how that applies in a course on computer graphics, where you've actually got to design a game or something, where there are many different moving pieces with lots of different states, and kind of figure out what patterns might be appropriate or what anti-patterns to avoid, and these sort of things here, right? Just going through that experience, right? Getting that domain. But then what I usually tell folks is, once you've explored a little bit, once something you've gotten sort of hooked on, again, whatever field you want to call that, whether it's computational biology, visualization, etc., whatever is sort of captured your attention, then try to do a deep dive. Again, whether that's through your formal study in your university or otherwise, following YouTube courses or whatever. Because the reality is, once you sort of pick a path and you get to see or work on a problem that's difficult and sort of beyond maybe what you would see in one course, and sort of taking that next course, I think it's just really useful to see or go through that journey and gain some domain expertise. So what do I mean here? As an example, you could choose compilers or graphics. I'll just use as examples because those were the things that interested me when I was an undergraduate student. Because the reality is, as you go deeper and deeper into a field like computer graphics, for instance, again, you get to revisit these algorithms and see, what it's about when it's not just sorting numbers and searching integers, right? How do I actually use some algorithm to build some partitioning data structure, right? So that's sort of the same idea that you'll learn about, quicksort, which is about, sorting numbers fast. That's how you kind of learn it, but it's really about learning about this idea of partitioning, right? So maybe you'll use or apply that concept to graphics and build some sort of partitioning data structure to arrange your scene. And you kind of have that tool in your toolbox. Or, if you're sort of in a 2D graphics world, when you learn about, 2D image algorithms or image processing, for instance, and you want to sort of do a flood fill operation, that's sort of like applying your breadth first or depth first search type of algorithm, right? The sort of thing that we're talking about here. So I think, as you do sort of a deeper and deeper dive in one particular domain where you can work on problems, you'll see again how these skills are applied. And then I think that's how the knowledge is really gained or made concrete once you can get beyond sort of the fundamentals here, as would be introduced. So it also, in a sense, creates a competitive advantage for you in the sense of if you've taken multiple courses on, say, computer graphics, and then you're going to go off for your maybe first job, or if you're transitioning to a new industry, right? Having a little bit more, depth in a sense in that field by, having looked at more than just the fundamentals and being able to draw from that experience. So, I mean, just to give you another example, and this is somewhat targeted towards a university student. Let's say you want to do game programming, but your university only has computer graphics. Well, again, try to choose something that could be in that domain, like if there's a computer vision course that's a little bit adjacent, but again, we'll show you how graphics are applied in some other industry. But again, you're sort of still doing a deep dive in that direction, right? If those are the only courses that you have. And then if you can, maybe if you're taking a machine learning course and there's a final project, maybe you can do it in computer graphics, for instance, and see how computer graphics is applying machine learning to solve various problems for whatever you're trying to work on. So doing a sort of deep dive in a domain and being able to have sort of a focused learning path, I found that to be beneficial versus saying, well, I'm just going to learn everything there is in computer science and taking one of each possible course. Again, just to be clear, what I'm saying is eventually it's a good idea to sort of do a deep dive into something and become sort of a domain expert, whether that's from a pragmatic standpoint, meaning that if there's job openings and you have lots of qualifications and skills in one area, that's a good thing that you'll sort of get hired for. But it also sort of just pays off with how you're able to think about things on sort of multiple levels as you proceed forward. Okay, so that's sort of my advice on breadth versus depth. It's fine to do sort of the breadth first search, looking around, searching, finding what's interesting, and gaining your fundamentals here. Okay, so again, if you're a university student, you'll probably have your fundamental courses. Don't worry too much. Those are going to set you up. So just focus on learning these skills the best you can. And really early on, the reality is your first job or internship, as I've noted here, you're going to have such a great deal of information about whatever you're working on that you didn't know you needed to know, so to speak, meaning you're just going to learn so much in your first job or internship, or if you're transitioning to a new role. I think it's not worth having the anxiety right away about like, how do I become an expert here, right? So if you're just early in your career, just focus on the foundations, but eventually, pick and choose, maybe explore a few courses, or if you know exactly what you want to do, I recommend folks do a real deep dive. You know, I just want to think about examples in the real world. Again, they maybe aren't, you know, I suppose they're inspirational stories that could be read about, but I think about programmers like John Carmack, for instance, deep dive into computer graphics, but now he's working on artificial intelligence stuff. And you just sort of learn how to learn as you do these sort of deep dives, so you can make a transition and even leverage some of those skills you learn in a different domain over into artificial intelligence, like all the mathematics and so on that goes on at these things. So those are just a few things to keep in mind. You know, that's sort of my breadth versus depth discussion that I like to tell folks. So I hope in a way this is somewhat self-explanatory, but those are the notes. I hope this has been useful. I hope you're enjoying these advice series. If you've got other ideas about things that you'd like to learn about, or just want my 2 cents, again, take it with a grain of salt, ask for multiple opinions, but this is what I found has worked in general well for folks. It worked pretty well for me, trying to follow this sort of path here. And of course, as you'll see in some of my advice videos, you know, once you do a deep dive into something, you can always change later. And again, those skills usually translate, right? That ability to work on a hard problem and build some skills in one area. All right, folks. So with that said, thanks for your time and attention on this topic, and I'll look forward to seeing you in the next video.